Good afternoon, everyone, and welcome to the College of Engineering Virtual Brown Bag Series. This is, believe it or not, the last but not the least presentation for this semester, and I hope some of you have attended the past ones and are looking forward to this one, which is going to be great as usual. So my name is Gautam Das. I'm the Associate Dean for Research, College of Engineering, and it gives me great pleasure to welcome today's presenter, a distinguished alumni from UTA. His name is Arun Bhikshesvaran, and he is going to be talking about a very interesting topic, exploring the C forces that are shaping the digital society. So Arun is the Chief Executive Officer of Radisys. And as I told you, he is alumni from UTA. At Radisys is responsible for the vision, strategies, and execution to further Radisys' role in the transformation of the telecom industry. He brings to Radisys a wide range of industrial experience and proven track record of leadership. Most recently, as a Chief Marketing Officer for MediaKind, he was responsible for creating and establishing the brand and marketing communication functions for a joint venture media technology company of Ericsson and One Equity Partners. He has also held multiple leadership positions, such as Vice President and Senior Leadership positions at Ericsson, Chief of Staff of Ericsson North America, VP of Sales, and a lot of other great top positions. So a lot of time spent at Ericsson, as I understand. He is an alumni of UTA, completed his Master's of Science degree, and is a distinguished alumni right now. In addition to UTA, he also has an executive certificate in business marketing from the Kellogg School of Business, and he's completed the executive program in strategy and general management from Columbia. So it gives me great pleasure to welcome Arun to today's presentation.
Thank you very much, Gautam. It's a pleasure to be here. Really sweet memories of my time at UTA a while ago, but had a fantastic time there, and was also had the honor of being recognized as a distinguished alumni. So the time that I spent in UTA, I should really say, shaped me in a substantial manner to what became a very fruitful journey, gave me some of the much needed orientation into what the right topics were to work on when I worked on wireless communications. And over the years then I've had the chance to really build on that. Due credit where it's where it's due given. Great time at UTA. So a little bit more about myself. After finishing at UT Arlington, I joined Ericsson, which is a Swedish telecoms company, has been innovating in the wireless domain for many, many years. I started out as a field engineer, and I spent about 25 years with the company, give or take 6 months, in a variety of roles that was spanning technology, strategy, marketing, etc. Had the privilege of being the chief marketing officer for Ericsson globally, where I lived in Sweden for about 3.5 years, and I've worked, with telecom operators all over the world. Since the middle of last year, I've been with a company called Radisys. Radisys is a 37-year-old, 38-year-old company that was formed by a couple of engineers from Intel in Portland, in Oregon. And Radisys has been at the forefront of driving everything that is open from whether it's a compute perspective or from a telecom networks perspective. And this is the reason why I actually joined Radisys, because the future is all about making things open, making things compatible, different kinds of software working with different kinds of hardware, etc. And I saw that as a key inflection point for telecom networks in general, and particularly fifth generation and fiber-based networks in particular. So that's the reason why I joined Radisys. It's a fantastic company, truly innovative people, lots of them. We have about We have about 1,000 employees in the company. Probably 92, 93% of them are engineers. And we're innovating across a multitude of domains. So that's what we do. Great to be here again. And I think I'll run through a little bit of my thoughts on the digital society, and from my perspective, what I think are the key forces that are shaping this digital society. I call them the C forces. This is just my own creation. So what I've kind of compiled, based on my experiences and my thought. So just to start with, of course, when we all entered 2020 from 2019, this thought of what the new times would bring, we all entered with a lot of optimism. And I think what we are heading towards is a completely different state that we call as a new normal. And at least in my head, when I write a weekly message to my entire team, to all our staff members, and I find myself closing these emails with this text that you see on the screen, which is, let's just stay safe and stay safe and stay healthy. And it has become such a cornerstone of our life now, that yes, a vaccine will come and we will all, become part of that that generation where we get the vaccine, etc. But this 2020 has underscored the importance of staying safe and staying healthy so much than probably at least any other period in my lifetime so far. And what that is doing is it is giving us all opportunities. If you put on a positive spin to this, it is giving us all opportunities to find new ways to learn, to shop, to take classes, even to get around, and also putting in another layer of perspective on how we take care of ourselves and the people around us. Right? To give you a little bit of context, after living overseas for a few years, when we returned back to the US, my wife is a physician. She's a general medicine physician. And so she wanted to find a way to get back into the practice of medicine. And this was a few years ago. She actually started with a telemedicine service. This is called Doctor on Demand. And it was a fascinating experience because at 6:59 a.m. she would be in the kitchen making a smoothie for herself, and at 7 o'clock she's in the study beginning her medical practice. And so she wanted to find a way to get back into. Sorry, there was a little bit of an echo there. So it was a great way. Dr. Das, is this still okay for me to continue?
Yes, it is.
Okay.
Can I ask you to unshare and reshare your screen, please? I'm having some technical difficulties. Oh, there we go. I think it's working now.
Okay. Do you want me to leave it like this, or do you want me to put it on a slideshow mode? Either one is fine. We can leave it like this if you want.
It's up to you, whichever you prefer.
Let's leave it like this. That way,
okay.
It's fine.
Sure.
So what I was saying was about my wife's experience with Doctor on Demand. It was fascinating, and this was a few years ago. And she's sitting here in the same room that I'm sitting now, and for 6-7 hours a day, she's working with patients, and it was a completely different experience for her in terms of not being able to see somebody physically, yet having to diagnose. And it must have been maybe after like a month or so. So she comes up to me one day and she says, you know what, I finally figured out what is common between our two professions. And I'm like deep into telecom and she's deep into medicine. And she says, this telemedicine thing is actually pretty cool. And, just imagine if the Apple Watch that several of my patients come now and are wearing can actually give me data back onto my screen rather than me asking them to actually take their pulse. And then reading it out to me, that somehow these sensors are connected and the data comes back to me. Now you fast forward 4 years, we are racing into a scenario where this is going to be normal, that we will use these kinds of devices around us to actually keep us all safe and healthy. and in many more ways actually control and work with different kind of equipment as well. So that is a super important kind of personal experience that we've had as well. And really that leads us to the last bullet that I have here on the slide, which says that the physical and the digital are merging in many, many ways. And really what 2020 has done is kind of accelerate that whole process of merging physical and digital. So with that, let me go and introduce. Can we try this play mode again? Just see if it works on.
Sure.
Are you able to see the animation? Is it okay now?
I'm still seeing a slide that says new times new normal.
Okay, how about now?
I don't see anything
Me
different.
neither. I don't see any animations.
Okay, then let's just go for this. What about now?
The connectivity, computing, crypto, cloud, commerce, community.
Outstanding, outstanding. So these are my C forces, okay? So you've got these 6 forces: connectivity, computing, crypto, cloud technologies, commerce, and community. These are the 6 forces that are shaping what I think is the current nature of digital society and how it is going to evolve. Each of these present building blocks on which other experiences are built in combinations, and we will explore some of these combinations. But let's take one step at a time. Let's talk about what each of these really mean. So if you take connectivity in the form of high speed, ultra reliable, low latency, wherever you want it. And there are 3 primary technologies. So I call it as a gigabit per second everywhere. You've got 4G wireless technology that is deployed, 5G being deployed now, and 5G has a very broad range of what it can offer, both from a speed perspective and from a latency perspective. And then, of course, fiber extending all the way to homes in a much deeper fashion than we have ever imagined. If you take 5G technology, for example, in the United States, we have AT&T, we've got Verizon, we've got T-Mobile. Everybody has implemented 5G in some form or fashion. And if you really sift through all the noise, there is 5G networks available on multiple frequency bands. So if you look at it from a wireless perspective, all the way down at 600 megabits per second, up to 28 and 39 gigahertz. You've not megabits per second, 600 megahertz, all the way up to 28 and 39 gigahertz. You've got wireless networks deployed across all these different frequency bands, and 5G deployed in many bands in between, starting at 600 all the way to 39. The 5G networks that are built using the millimeter wave spectrum, which is in the 28 gigahertz and 39 gigahertz, we have seen, and we have technologies that are being rolled out now, where we can deliver 6.5 gigabits per second over the air, 6.5 gigabits per second. So I'm talking gigabits per second everywhere. This is, we are able to aggregate 600 megahertz carriers, each carrier delivering a gigabit per second. And you've got phenomenal performance that you can achieve with that kind of stuff. And that is from a raw speed perspective. What is also being worked on is the ability to have many, many millions of sensors connected to these networks. So in the case of wireless networks, one thing is what throughput you can achieve. Another one is how many devices can you have connected at the same time? So that is massive machine type communications. And then when you've accomplished these 2 things, the third aspect, which is very important, is what is the latency that you can operate these devices with? Because some applications, let us take a self-driving car, for example, right? You can't have a lot of latency on that. When the computer on the car decides that it has to switch lanes, it has to happen at that particular time when the computer decides it's the right time. A second of latency could lead to a catastrophic outcome. So the latency in these communications starts to become very, very important. And so we are working to optimize all of these things from a connected perspective. I'll give you another example. We have as a customer in Radisys a company called Philips, which is dealing with a lot of healthcare stuff. And I had the chance to visit their headquarters in the Netherlands last year. And the gentleman who was giving us a tour talked about how it took them 3 years to develop a wireless foot pedal for their surgery table. And he said, you know, this is a foot pedal. When the physician or the surgeon presses their foot on the pedal, whatever needs to happen right away. Because if it is another 2 millimeters inside the body where it's turning, the catheter is turning, it is taking a wrong turn at the wrong place. So he said, just to reduce latency, it took us 3 years to perfect this technology from a wireless perspective. So connectivity in that sense is going to completely change what we do, especially wireless connectivity, on what kind of things are possible to connect and actually bring to life. So that is one thing. The second thing is about computing. And I use the term elastic here, because what you want computing to behave is you want it to be super adaptive. You want it to scale up when you want it, and you also want it to scale down when you don't need it. So a very good example, I think a lot of us, probably all of us, have smartphones. And one of the things that happens on smartphones, if you see, is that the display shuts off. Now, why do we shut off displays? Because we are shutting off computing capabilities and capabilities that consume battery power when not needed. So we scale it down so that when we need it, we can scale it back up to display what is needed. Now, imagine if you can do these kind of activities on a very large scale, that you turn off or you ratchet up and down computing power in an elastic manner when you need it and when you don't need it. That has got tremendous benefits to it in terms of longevity of devices, but also energy consumption, etc. And making it ubiquitous and learning at the same time is another aspect that is very important. So, for example, if you take the issue of self-driving cars, okay, and this is one of my favorite things. So you think of a traffic light at an intersection using 3 colors. In many ways, this is a very primitive signaling system. It uses 3 colors to tell you whether you're prepared to go or you have to stop or you can go now, right? I mean, you're red, amber, and green. But in a system where so many things are connected, do you really need to use these visual signs? Can we provide these as electronic signals? Can we provide these in a manner where a car is getting information about the traffic light, not just in the current intersection that is in, but in the next 3 to 5 intersections, so the traffic flow can actually be regulated in a much more comprehensive manner? I mean, if you look at it today, a Tesla car that comes out has, okay, let's say many cameras. But to have a camera to read a traffic light sign is taking a very sophisticated computer and asking it to do some very stupid thing like reading the colors. We don't need to do that. If the traffic light had a computer and connectivity that could actually emit the signals, all cars at that intersection and approaching that intersection will actually get these signals transmitted, and they can then decide at what speed they should approach or take off. And the ability to control traffic flows across a wide area of the city will be completely different. And this is where local computing starts to become very important. And that is what leads to ubiquitous computing, for example. Just as one example, you could have computing in so many different environments. And what you want then is a method where the system is learning on a continuous basis. So time of the day, day of the week, week of the month, traffic patterns is a great example. And if you can start to predict, and if you can start to already direct flows based on what the situation is in a certain city. So my wife goes to the same destination every day. So she leaves at a certain time, she goes to the clinic, she practices medicine, and she comes back home. It all happens at the same time. But I can tell you, the time it takes on Monday morning is very different from what it takes on Friday morning. And the time it takes on Monday afternoon to come back is substantially different from the time it takes on Friday afternoon. She's taking the same route. Now, could we optimize the flow so that we could guarantee that the travel time is the same, but the route is different, so that the traffic is spread out more evenly in the city, rather than just delaying people in putting them in queues where not all roads are loaded, but 30% of the roads are loaded and 70% of the roads are just staying empty. Could we do stuff like that? So that is where your learning system comes in to make things more efficient. Cryptography, very important to secure that the information that we all use, that the information that is used by computing infrastructure is absolutely protected and safe. This is essential to make sure that we can guarantee privacy of the individual, privacy of the data, and integrity of the systems. And I don't have to say enough about the integrity of the systems. We have an ongoing public dialogue on that in the nation today. But then cryptography becomes super important in that context. And more we can make it multi-factor and actually biometric. So I was in a session today earlier where we were talking about the use of facial recognition in public places. And how do you still do this in a manner where the privacy of the individual is protected, but you can really get it to be very, very sophisticated in terms of what people are allowed to do. If I give you an example, I don't know how many of our people here have been through the Hong Kong airport. When you exit Hong Kong, it is a truly fantastic experience. There are 2 gates, and it is a 100% automated system. The first step, what you do is you actually scan your boarding pass, and that says that okay, you have a valid boarding pass on a particular flight. So the first gate opens. And when the first gate opens, you walk in, the gate closes behind you. And now you're sandwiched between 2 gates, both of which are closed. At this particular time, what you have is a facial recognition system that kicks in. And they take a picture of your face and the biometrics. And if everything tallies with the information that they have, the second gate opens and you pass. And this is 100% automated. There is no manual intervention. And you just step through this. And it is highly systematic, and you just go through this, in this kind of fashion, and it's highly predictable because everything that is happening is based on compute and its data, and there is no manual intervention. So manual intervention becomes an exception rather than the norm. So the use of biometrics and of course making sure that the information is safe is another big thing that is going to come in. You talk about Zoom conferences, you talk about team conferences when people hack in. There are technologies available today, even something that we are working on, where every person is allowed to join a meeting only after their biometrics are verified, so that you have the right person, the right people, the right actors coming into the right audiences. Cloud as the 4th C force. I'll tell you about accessibility, making things accessible for everybody. I think that's a great thing. But I'm going to skip to the last one, which is probably the most important. The cloud is a great equalizer because it takes everything, whether it is knowledge, information, entertainment, communication capabilities, storage, etc., and puts it in a way where everybody has access to the same attributes. And I think the best example, and I think I have a slide on this probably, is Khan Academy. You think of the content that is available in Khan Academy, where there is so much of information that you can just spend hours learning. And Khan Academy was among the first. You've got other people now too. When I was in Ericsson, we worked on a program called Connect to Learn, where we provided our wireless communication system to connect a school in Ghana, in Africa. And when our executives then went to visit the school as part of an Africa customer trip, and when they were about to land on the premises of the school in a helicopter, the kids in the school had actually formed a pattern saying, "Thank you, Ericsson." And our executives were a little bit taken aback. They had not realized the impact that they had on these school children. But what they realized when they landed on the ground was that connectivity had made Khan Academy content available to a remote girls' school in Ghana. So a person sitting in New York City or a person sitting in San Francisco had access to the same information as what these kids, or the reverse, the kids in Ghana had the same access to the same topics that was available to a person in San Francisco or New York City. So it serves as a great equalizer, making things available anywhere, anytime. Talk a little bit about commerce. There is a massive shift in how commerce is taking place around the world in terms of both the integration of the physical and digital, where you do digital shopping and the physical goods are delivered, and more of the stuff that you would have never even conceived buying in a digital fashion, you start to consume that way. And that transformation is happening in an accelerated fashion. And of course, along with that is how payment starts to get handled. And if you combine this with what we talked about with cryptography and biometrics, and this you start to see with something like Apple Pay now, where you use facial recognition or your fingerprint for making payments, and you can do that from your computer, you can do that from your smartphone. There's a huge transformation that is happening here. And finally, the sense of community, which is that everything that we do today is being shaped in many, many ways by how we interact with our community. Community that we know, that we are familiar with, and that we do common experiences with, whether it is learning or social engagement or entertainment, and community that we don't know, but we still value their opinion when it comes to commerce, for example. We don't know who this person is, but if that person has a reputation score that is high, then we kind of start to value the opinion of that person. And when it comes to a shopping recommendation or a travel destination, etc. So these forces are all coming together in a very significant manner, and they all connect with each other with this centric approach to really create the C forces. So having said that, let us talk through a couple of examples to see how these really come to life. And I want to take this example of the convergence of transportation and healthcare. What you see here are two pictures. The one on the left side is a company called Zipline, and the one on the right side is from a company called Matternet. So what these companies are doing, and you see both of these there is a picture of a drone. So the one on the left has a fixed wing drone. It's an electric driven, you could call it as an aircraft, but it's not really an aircraft, it's just a drone. And what it does is it takes off from a point and it never lands anywhere else. It comes back to the same point. So the takeoff and capture or the landing mechanism are super defined. But what it does in that trip is just it delivers a package at a predefined destination. And where it goes is defined by the connectivity capabilities that it has. So it has a microcellular connectivity and it's electric powered. And this is in operation for a hugely humanitarian purpose, which is the delivery of blood. So in an African country, so what happens is with blood is, of course, it's a highly perishable item. So you've got to make sure that it is stored in an absolutely safe manner at the right temperature and everything until the time it is really needed. And when it is needed, it needs to be delivered with precision to where it is needed and in a very, very fast manner. And if you don't have infrastructure to preserve blood in a good way, then there is a huge potential for loss of blood, of the efficacy of the blood. So what Zipline has done, together with, I believe it's in Rwanda, there is a centralized blood bank where all blood is needed for a certain fairly large geography is stored. And as and when centers within that geography need blood, Zipline delivers a package that consists of blood. So the red thing that is falling off this drone that you see actually has a blood capsule inside. And it's got a parachute, so that what you see as hanging in the top is a parachute that at the right point in time, the drone just drops it off, the parachute slows it down, and the people on the field or wherever, they're able to just get this blood package delivered to them. What you see on the right side with Matternet is something similar. That is a 4-scope drone there, and you've got blood samples that can be transported back and forth. So Zipline, where it is a one-way delivery, Matternet can actually transport it both ways. So it can go pick it up from a hospital and take it to another central location where blood analysis can be done. So these two things, and I put their mission statement there. So this is all, by the way, all information that I'm presenting is proprietary to the companies that own the trademarks. So I'm just using these as examples. So and Matternet's goal that you see there is making access to good as frictionless as universal as access to information is. And what they've started on with is this case of blood delivery. We've talked about, I brought up Khan Academy earlier from an educational learning perspective, but what you see at the very top of the slide are two words, which is access, pace, continuous, and outcomes. So Khan Academy started in an era where access was the most important thing. Now we are in an era where access is interesting, but you really want to see if you can use that to produce certain measurable outcomes. And that is where the picture that I have on the right side of the screen, which is a company called Imbibe, it's an Indian organization that is focused on making content available, whether it is tutorials, whether it is tests, or even live one-on-one tutoring, so that they can actually positively influence the outcome of students on a mass scale. The first statement below my title, which says provide a free world-class education to anyone, anywhere, is from Khan Academy. The second one is from Imbibe, and how you can actually use learning and what we called as computing earlier, learning mechanisms in the back end to deliver something that is tuned to every student, so every student can actually improve their performance. So it's not just about sitting in front of a computer screen and listening and not knowing whether you really grasped it. You have a custom learning package that is created for you where you can actually improve your outcome. So it's a pretty phenomenal service, and it happens to be one of our sister companies in the group where Radisys is part of. Moving on, another company that is doing great work in healthcare and working on something called as a health continuum is a company called Philips. Philips happens to be one of our customers as well, like I mentioned earlier. And their approach is truly dramatic in terms of taking it from living and the way you live and to the point of care at home, and how they can actually democratize information and instrumentation to make it super valuable across, you could almost call these stages of life, and how you've got to make sure that people are taken care of across the board. And they have products ranging from a connected toothbrush to a sleep-inducing pillow, to an air fryer, to surgery machines, CT scanners, image-guided therapy, and total diagnosis. The way they operate across the spectrum is truly phenomenal. We are collaborating with them on a multitude of projects in Africa and in Asia, where they bring to bear all the different technologies in a very human manner, because what they say, as you can see, that their purpose is to improve people's health and well-being through meaningful innovation. So while a lot of people in the medical profession get paid by the number of people that they see, the mission at Philips, focusing on well-being, really goes beyond just treating symptoms, but really taking care of at a human level. So I find that tremendously motivating. And just so that you can track, in the top right corner of every slide, I've kind of highlighted in an orange-yellow color which of the C forces apply to each of these cases. So if you take transportation and healthcare, you see it there, and you'll see them highlighted on each of these slides. Another area of transformation, tremendous transformation, and I'm sure some of you have probably seen this. If not, I would really ask you to check this out. This company does, it's a company called Starship. So if you want the URL, it's starship.xyz. And Starship, as opposed to drones, this is a drone on wheels. So this can navigate, this vehicle can navigate, and if you see on the right side of the vehicle, what you'll see if you look intently is actually a camera. So the front of the vehicle, so you're seeing the side view now. So the front of the vehicle has cameras all around, and it's got sensors around. And this is an operation in many cities across the United States. We have it here in a neighborhood in Frisco, where I live as well. And what this allows you to do is to have a hassle-free shopping experience, whether it is for groceries or for restaurants, which is what they do here in Frisco and in several parts of New York and San Francisco as well. So the restaurant after you order the food, this is a refrigerated truck, if you would look at it that way, but it's tiny. So the restaurant is able to open the top lid, put in your food, it locks, and it knows where it's supposed to go. And it makes its way to your doorstep. And when it is arrived at your doorstep, it sends you a signal where you can go outside, you authenticate yourself, you can open it, and you can pick up your packages. And then when you're done, this device will go back to its destination, or to where it came from, or to the next stop where there is another package ready for it. And if you have not seen it, I would really encourage you to go watch some of these videos, how this device can stop at a pedestrian crossing and actually cross streets. So we're not talking about Mickey Mouse stuff here. The level of computing that is going on is phenomenal in this particular case. And it is a great innovation, especially during these times where you can't have that many people inside a shop or that many people inside a restaurant. You know, it makes those businesses also possible to function and for people to get the goods that they want in a completely touch-free manner, in a very safe manner. So it kind of connects back to this staying safe, situation that we are in as well. I've got a couple of more examples, and then we can try to kind of wrap up. Another very big example of what is happening, one great force when all these things come together, is what is called as mixed reality or hybrid reality. What you start to see here, actually, let me do it like this. How about if I do it this way? Let's start there. And I can put that picture back. This is an example of a mixed reality experience for somebody who wants to buy a car. Okay, so you go into imagine this as a modern car dealership where these cars are expensive. Some of these cars are not made until it is actually needed, because then you don't have to have cars manufactured who are sitting at various points in the supply chain. And you've probably seen pictures from a harbor where cars have been delivered on a ship to a parking lot, and some of these cars are standing there for 6 months, 7 months before they're sold. There's an enormous amount of capital that gets locked in. But if you can allow people to still go into a dealership, they can see the sample cars, but then they start to customize the car that they want through a goggle like this. They can in real time see how they can customize the car. And what you see here is a combination of a headset that people can wear and an edge compute node that can do these computation in real time, and a car that is customized for you that then gets delivered within a certain period of time. It is optimal deployment of capital across the chain, but it really allows you to have a very, very different experience on how things work. So there are many different technologies that go in to actually create experiences like these. So for example, in this particular goggle that we have worked with in another sister company that we have called Tesseract, there are 7 cameras that are inside one frame, and there are 4 cameras that are just tracking your eyes, and they are inward facing, so they're not actually outward facing, so that people can actually track what you want to look at and then tailor the experience of what is presented on the screen based on where your eyeballs are, and then doing the eye tracking, and then actually mixing and providing the overlay between what is physical and what is digital, and doing this in a ultra low latency fashion with enormous amounts of bandwidth. This is when all of these actually come together to create fantastically new experiences. One of the things that we did actually in my earlier company, MediaKind, we provided what is called as a 360-degree stream of a basketball game. And we did this together with an operator in Germany called Deutsche Telekom, T-Mobile here in the US, where we had 2 360-degree cameras mounted inside the basketball arena, and one of them is actually on top of the hoop. And you as a viewer can actually, either through wearing a goggle or even through a flat screen from an iPad, you can get a complete 360-degree immersive experience of that game. And just imagine you're sitting there and you watch a replay from the perspective of the who. You see the whole court from a completely different angle, and you can construct your experiences. You can actually turn around and see what the person behind you, how they were reacting. And imagine if you could put yourself in an arena where you are experiencing that, but you're in the comfort of your home. You can actually get a fantastic experience of what it would be like as though you were there physically. And these kind of experiences are being made possible. And with that, we go to the last example here, which is a true mix of all the things that we have talked about from a transportation perspective, from a connectivity perspective, from a computing perspective, from a mixed reality perspective. Is a company called Waymo, which is began by Google, and I picked up this example because what they are doing is inventing core technology that can be used by probably many different manufacturers. But and this is a trademark slogan from them, so I want to give them 100% credit for this. We are building the world's most experienced driver, and that is not a human, that is a machine, and that is just going to provide an ultimate level of safety, not for every individual, not just for every individual, but for everybody on the street, because that is what happens when you have one rogue individual that can disrupt many things. So to create this and the using of technology, and what you start to see here, for example, I talked about this traffic light and the visual signatures. You start to see a go sign here on the right side picture, but that go sign is a visual representation only for the people who are not in the current generation of technology. There is an electronic representation that is going out to every car as well, so that the cars all get the sign. They know their exact position in the queue, and depending on the go sign and the number of cars that are in front of them, and knowing how long the traffic light is going to be in the go state or in the green light state, they can actually pace themselves on whether to accelerate or whether to do a slow roll, because they know they're not going to get their chance. So much sophistication possible, and these are all technologies that are in various stages of maturity around us today. So these C forces, as I call them, working together to really shape what we are all going to be living in, the digital society, where we will all be interacting with each other, machines will be interacting with each other, we will be interacting with machines, and that is going to be a new normal as to how we're going to be leading our lives. So that is what Gautam I prepared for today. Hopefully it was a little bit interesting. I'd love to hear some questions or whatever we want to do now.
Thank you, Arun. This was really a great talk. I mean, I think most of us in the audience have heard these messages in bits and pieces, but I think the way you put them all together and put them under this umbrella of C forces was really a great unification attempt, I think. So you really painted this brave new world where we are hurtling towards, and sometimes disruptively so, like, for example, what the COVID has done to us. Many of these technologies that were, on a path towards maturity have certainly taken up urgent proportions. So as you can see, right now we are talking on Zoom, which has become kind of the norm in education, as opposed to classroom teaching. So we have a lot of, I have a lot of questions myself, but I want to look at maybe a few questions that the audience have already typed in their chat boxes. So there was a comment early on. So this is really not a question. This is from somebody from the audience. But the comment is, it's incredible how Apple has integrated the ECG and the O2 sensors on their watch. I don't know if you want to comment on it as to what's the underlying technology behind it, or whether you agree that it's an incredible feat. So this is really a comment.
Yeah, so I agree with the comment. It is an incredible feat. And see, it has to go to this underlying purpose of why you're doing what you're doing. So because there are so many things you could integrate, and to be able to choose a couple of those things that can have a very meaningful impact on people's lives. I think they've done a remarkable job with that, coupled with fall detection, for example. There is so much that could be accomplished with that. On a very personal note, my father-in-law had a stroke. I think it was 2 years ago, something like that. And the root cause eventually was turned out to be AFib. And the next generation of the Apple Watch coming out literally 3 months down the line, or maybe it was just 45 days down the line, had AFib built in. And then we were like, man, if we had just gotten them, if the timing had just been a few months this way, that way, we could have actually detected that he had AFib. And it could have had a very, very different positive impact on his life. So it is amazing how they are able to do this. It is a fantastic integration of human purpose and technology and aesthetics as well to really bring to bear something like this. I use it every day. I have the latest one with the blood O2 sensor and everything. It is a definite boom.
Yeah, I think the O2 sensor is particularly useful these days, especially with COVID as a potential, disease that is going all over. So it's great.
Absolutely.
Another question from the audience. So I guess this is more of a sort of a definition question. So this person is asking, is crypto just means safe? I'm not sure what the intention of the question is. Maybe you want to just define what is, crypto, as you mentioned in your talk. So that might be good.
Crypto, for me, what crypto means is to secure. And there is an underlying technology associated with that, which is cryptography and the algorithms and everything that go along with it. And I used it here a little bit to make sure that I can still conform to my C forces, etc. Right? But at the end of the day, it is the ability to identify information, to secure that information in the right manner, even when it is getting transmitted from one point to another, and then to ensure that only the right people who need access to the information, who are authorized to have that information, can actually have access to it. So I've tried to capture all of that in that thing of crypto. It is about safe transmission, it is about secure transmission, but it is also about doing it in a manner where it is more easily accomplished in a multitude of endpoints. Because you see, one thing that happens is in this era of 5G, when you're connecting so many different things, the attack surface is infinitely larger, right? Or many times larger, not infinitely larger, exponentially larger. So you've got to secure every single endpoint out there as a potential attack surface, and that is where you've got to be able to miniaturize it enough so that every point can be secured, and at the same time the information can be transmitted in a safe manner. So that is the way I would define it.
Okay, great. So there's another question from the audience. Let me see if I'm scrolling through it the right way. So what are some of the ethical challenges that you think will arise with the application of C forces into everyday technology?
Yeah, we think about this all the time. One of the things that we think about mostly is around the technology of facial recognition, because what you start to get, there is a potential to get really intrusive if you don't handle this information properly. Because in order to do facial recognition, of course, you need cameras all over the place, and when you put cameras in there, the consideration of you are now taking what was previously not 100% private space, but available for viewing only for the people who were there physically. Now you've created the ability for that information to be available anywhere at any time. So there is a high ethics consideration there as to how much you're being intrusive there, and what you can do to actually anonymize it, create a wireframe, etc., and use the technology for the right intent and the right purpose, rather than just going out everywhere. So that is one thing that we think about. So that is a little bit of a problem with facial recognition that we have to be aware of, especially when we deploy it in large areas and you've got cameras all over the place. It could be used by not so good people for all kinds of bad activities and bad actors, etc. So that is one thing that straight away comes to mind when we talk about this, and we've got to be careful with it.
Great. The next question, I think you've alluded to, you've given a bunch of answers already, but maybe you can add a few more. So do you see any new promising business models based on these new technologies?
Yeah, absolutely. I would see this principle of sharing economy is one business model that to me is still in a very nascent stage, and I think where it is coming to life now is definitely in the automobile industry, where there are companies that offer sharing of cars on a subscription basis, etc. So you don't have to buy a car; you can change your mind every day if you want on what kind of car you want. I think there is Sewell dealerships in the Dallas area that can give you a new car every day if you want. It's a pricey subscription, but if you're of that kind, you can experience that. But that is just that is only a business model. There is no underlying technology associated with it. But there is a company called Lynk Co, Lynk and Co, where they have created a car that is meant to be shared. So it's got soft keys, it's got shareable keys that you can generate from your mobile. Different people can use it. The car is not with you if you don't want it. It can drop you off, and it can go run errands, and it can be used by other people, etc. That kind of business model where the cost per user, the cost per usage dramatically goes down, and the equipment is not lying idle for a majority of the day, which is what in a pre-COVID environment, if you think about it, a lot of us would drive for 20 minutes, 30 minutes to a destination, and then the vehicle is sitting there for 8 to 10 hours before it is time to drive for another 20, 30 minutes to go back. And during those 8 to 10 hours, it is depreciating. There is no meaningful value generation for anybody that is happening during the process. So there is a lot of things that can be done with the business model, and I think it is starting to begin there, and it will have a number of positive effects in terms of environmental benefits, etc., but also in terms of using resource in a smart way. So that is one business model that kind of comes to mind that is very real, that also connects back to some of the examples that we've talked about with autonomous driving, so on and so forth.
Great. Another question, interesting one, I think. Do you believe the widespread, I guess, use of or adoption of digital currencies backed by cryptography is being pushed back by the threat to our current banking systems?
Actually, I'll give you, I don't think so, is a short answer. And I think it has actually gone in the other direction, at least in one country, where I had a chance to experience it personally as well. We were living in India some 3 years ago for a couple of years on an expat assignment. And when we were there, the government decided to demonetize a set of currency notes that were out there in circulation for various safety reasons, etc. And what I experienced over the next 30 to 60 days in India was a dramatic increase in mobile payments, not just electronic payments, but mobile payments coming out in all forms of fashion. And eventually, what we have now available in India is a unified payments interface that every bank uses, every payment authorizer uses. Even WhatsApp payments now that is in India has to use that same programming interface, and that has really created a highly secure interface for mobile payments, mobile transaction, person-to-person money transfer, and it has dramatically cut down any inefficiencies that existed in the system and making money transfer possible between the right actors in an extremely fast manner. So I do believe that it is moving in the right direction, and we've got to make sure that it is taken care of from a security perspective. But from everything that I've seen personally, I think it is moving more in that direction. And you see it here now, even with Apple Pay or Samsung Pay, for example, wherever you go, there is increased propensity to use these kinds of mechanisms.
Yes. So I have a question of my own. It's more of probably a philosophical question than anything else. So you mentioned that technology is getting to a point where human intervention is more of an exception rather than the rule, and that's the way it should be. But in contrast, there is a certain group of thinkers who believe that humans still play a pretty central role in some of these digital technologies and digital systems. And in fact, if you look at some of the new trends of research in artificial intelligence and machine learning and all that, human-in-the-loop computing is becoming a trending area where the humans have to be an integral part of the data science pipeline. They have to inject their intelligence, their experience to make things work, and just left all alone by automation, you are most likely going to get catastrophic failures every now and then. So this is a philosophical, there's no way to defend it or attack it, but I'm just wanting to know your thoughts about it.
No, I agree with you, Gautam. I think there is tremendous human value in the chain, in the overall efficiency and validity of the chain. It is just that when you blend it with technology and the right kind of technology, as long as you can reduce the number of human dependent errors in the system, the safer the application of technology starts to become. I'll tell you personally, what I've started to do now, I don't use any navigational lanes when I drive, because what I've started to realize is that you've kind of become a little bit immune. You kind of use it as a first nature to punch in where you want to go, or you talk to a Siri and you're blindly following directions, which means you're losing your human ability to actually think. And not just think, but even from a memory perspective, what turn do you take? How do you get from point A to point B? So I did a very interesting experiment, and it must have been about 2 months ago. I was going to take my daughter to the optometrist, and I said, tell me where this optometrist is. She's like, I'm not sure I really know. I'm like, so you don't know, so you're a driver, you don't know how to get to this place. She said, no, I just know, I just turn it on Apple Maps. I said, okay, so we're going to try an experiment now. Don't tell me how to go. Tell me what the location is, the nearest street intersection. And I said, if I get to that intersection, will you be able to navigate me from there as to where you need to go? Because I've never been there. She said, yes. So I said, okay, just tell me the street intersection. And it was like a challenge for me until I got to that street intersection. I was like, okay, do you really know how to get to this point? And you've got to exercise your brain. So there is that aspect of human survivability as well, that we don't become a slave to machines. And we have our own faculty that we have to maintain as well. So I think there is a role for humans, absolutely.
Okay, so let me ask you one last question, and hopefully we can wrap it up before the hour. So what does all this have to, what kind of impact it will have on workforce training and development for the future? I mean, are we really running a risk of a lot of people who are unable to, for a variety of reasons, to adapt to the new sort of world, being left behind, not being useful, not being able to find gainful employment? Do you foresee a black period of this kind rather than the utopian world that you've been basically describing?
I don't think so. And the reason is this. Even in this world that maybe we have described, there is still a lot of physical actions that need to take place. A lot of work that is of different levels of complexity that still need to be accomplished. And I think there is going to be a role for people with different sets of capabilities to be able to do that. In our company, what we have experienced, because of COVID, we put of course, a work from home policy for everybody in engineering. 50% of our staff are not even located now in the city where we have our office. 50% have gone away to, wherever they feel comfortable working from. But I'll tell you something. We all connect on a daily basis, but we still need a few people in our labs every day to make a physical connection, to move something from point A to point B, to take out a piece of equipment and to refresh the piece of equipment. And there are a bunch of people who are needed to configure those equipment, who are our engineers who need to be there. So it is not, everything is not going to be in this automated world. There is going to be different levels of sophistication that we will have to adapt to, and that has always been the case. Even in the era of man landing on the moon, there were some people who are working on that project, and there's 99.99% working on other things that are needed for society to run. So I do believe that that will be the case as well. The skills that are needed will be different, and people will need to learn new things and selectively forget some old things. Even you and me have to do that. I think there is going to be what you know and what you do is going to be different from what it is today. 5 years down the line, the kind of engineers that UTA puts out, the kind of talent that they have to come out with, the kind of knowledge base that they have to come out with, I believe will be different from the people who are graduating this year. And this is going to be happening every year.
Absolutely agree. Well, we are right on the dot. It's time to wrap up a very exciting session. And thank you, Arun, for finding time from your valuable schedule to give us this exciting presentation. I'm sure everybody who was attending enjoyed it. And that wraps up today, and that wraps up our virtual brown bag series for this semester. We will be restarting it next semester with a series of another great speakers. Thanks, everybody, and have a great afternoon.
Wonderful. Thank you very much for the opportunity.
Thank you.
Okay, bye-bye.